we have, so for x, if log 2 minus 3x to the base 3 equals log 6x squared minus 19x plus 2 to the base 9. Now you can see that here the bases are not the same. So we can't just start solving it straight away. So anytime you realize that you have a log equation whereby the bases are not the same, it means we can't just solve them straight away, but we have to try and change one of the base to the other. Here is base 3. It's either we change base 3 to base 9, or we change the base 9 to base 3. And as you can see, the easiest way is to change the bigger one to the smaller one. Okay? So here, base 9, you can convert base 9 to base 3 using the change of base law of logarithms. Using the change of base law of logarithms, you can change base 9 to base 3. Let's see how we can deal with this particular problem. So over here we have log to the base 3, 2 minus 3x equals, so here we are changing the base and we have to apply the change of base law. So when we are changing, our new base is now 3. We are taking a new base of 3. So we have log to our new base of 3, 6x squared minus 19x plus 2, okay, all out of log to our new base of 3, okay, to the old base. So this is what we have. This is what we call the change of base. You see we have changed the base to a new base of 3, okay? And this is what we are getting. So we can move further. Log to the base 3, 2 minus 3x, okay, equals log to the base 3, 6x squared minus 19x plus 2, all out of, now you can see that here, this 9 can be converted to indices. We can have 3 exponent 2. So we have our log to our new base of 3 exponent 2. Okay? And this is going to give us log to base 3, 2 minus 3x equals log base 3, 6x squared minus 19x plus 2, everything out of, here our 2 is going back to multiply the log, so log 2 log 3 to the base 3. I will say that this one is going to give us 1, log 3 to the base 3 is going to give us 1, and 1 times 2 is going to be 2. Okay, so this is going to have, this is going to give us log 3, 2 minus 3x equals log to the base 3, 6x squared minus 19x plus 2. Okay, all out of 2. So this is what we have. And here what we're going to do is, there's an equal sign here and there's a fraction here. You can cross multiply. You can cross multiply, or someone will say multiply through by 2. Okay? So anyway you do it is the same thing. So if you cross multiply, you're going to have 2 log 2 minus 3x all to the base 3. And this is equals to log base 3, 6x squared minus 19x plus 2. Okay. Now, as we can see, there's 2 over here. These 2 can go back to its original position, right? From the laws of logarithms, these 2 can go back to its original position, and this is going to give us 3x all squared equals log to the base 3, 6x squared minus 19x plus 2. Okay. So that's what you have. Now you can see that the bases are now the same. Base 3, base 3. Okay. So here we can take antilog of both sides. And when we take the antilog of both sides, we are going to have 2 minus 3x all squared to be equals to 6x squared minus 19x plus 2. That's our new equation. So from here we can expand this bracket because there's a square here. We can expand it. If you know how to sing the song, we square the first. So you have 4 twice their product. So their product is 2 times this minus 6x twice will give us minus 12x. Then you square the last, which is plus 9x squared. Equals 6x squared minus 19x plus 2. So here we can see that there's we can group like terms. We can group like terms. So we have 9x squared over here. Let's bring this ones here. So when we bring this ones here, we are going to have 9x squared minus 6x squared, because 6x squared is coming. We are going to have 2 the 3x squared. Okay? So we have 9x squared here. When 6x squared crosses to this side, it becomes negative. So when you subtract 6x squared from 9x squared, we are getting 3x squared. Then we have 19 minus 12x over here, then minus 19x. So minus 19x is coming. So when it comes here, it becomes minus 12x plus 19x. And this is going to give us positive 7x, right? So when 19 comes, it becomes positive. So minus 12x plus 19x. So you do the subtraction, we have 7x. Then we have 2 here. When 2 comes, we have 4 sitting here already. When we do the subtraction, we have plus 2 to equals to 0. This is your quadratic equation. So from here, using factorization, we multiply 3 by 2. 3 times 6 is going to give us 6. Okay, so with the 6, we need 2 numbers. When you multiply, you should get 6. When you add, you should get 7. Okay, and I think 1 and 6 will do, right? So we are going to have 3x squared plus x, which is 1x, plus 6x. So 6x plus x will give us 7x, plus 2 equals 0. Okay. So this is what we have. 3x squared plus x plus 6x plus 2 equals 0. Now we can put them over here. Group them nicely and factorize. Now we have 3 here, there's no 3 here. We have 2 of the x's over here. 2 of them. And we have 1 x over here, so x can come out. Okay. So when x comes out, now 3 here will be left with 1x plus, this one have to move out, so it is left with 1. Okay. Plus, over here there's 6 here, there's 2 here. Now 2 is a factor of 6, so 2 can come out. Now there's x here, there's no x here, so it means x cannot come out. So let's bring 2 out. So now from 6, when 2 comes out from 6, we are left with 3x plus, this our 2 has come out, so we are left with 1, and this should be equal to 0. Okay. Now we can put these ones together, 3x plus 1. Then those at the back, we put them in one bracket, 1 plus x plus 2, and this should be equal to 0. So it's either this one is equal to 0 or this is equal to 0. So if this one is equal to 0, then it means we are going to have x to be equal to minus 1 on 3. Okay, minus 1 on 3. Or if this one is equal to 0, It means we are going to have x to be equals to minus 2. Now, this is the solution for the problem. The solution find the values of x. Okay. So x is either equals to minus 1 on 3 or x is equals to minus 2. And this is the solution for the problem.